students to the problem that was skipped on your review sheet, and I do apologize for that. Page 920, number 23. Now, before we get into this problem, I want to talk to you about something, okay? I have to teach you, not teach you, I have to review an old elementary, middle school principle that you need to see, okay? If I told you I would pay you $200 per week to do something, and then I told you I was going to give you an 8% increase. You know, this has nothing to do with the problem that we're doing yet, but it will. You have two ways to solve this. You could take 200 times 8%, which is 0.08, and you would get $16. So your increase is $16. So your new salary would be what? $216 per week. But there's another way to do it. I'm not sure. You guys should remember this. Anytime you're dealing with an increase, instead of multiplying this figure 200 by 8% and then adding it, what you could do is say, okay, it's an 8% increase, so I'm going to multiply 200 by 108%. You add 100% to this. Well, 108% would be 1.08. Well, if you take, to watch this, if you take 200 times 1.08, you get exactly 216, so it's a little faster to do it that way, okay? Now, if I say it was an 8% decrease, because you weren't working very well, so it's going to lower your pay, well, then what you would do is you would multiply 200, and instead of adding 100%, you would subtract this from 100%, so you would multiply 200 times 92%, 0.92, or if you wanted to, you could take 200 times 8%, get 16, and then take 200 minus 16, and you would get $184, or you could just take 200 times 0.92, and you'll get the same thing, $184. We're going to use that principle today in this problem, okay? So here we go. The problem in the book reads as follows. To create a college fund, a parent makes a sequence of 18 yearly deposits of $2,000. Now what that means is every year this parent is putting $2,000 into a college fund. Okay? Not just once. Every year they're putting $2,000 more into it, okay? Alright. It's compounded annually, so once a year the interest is found, and the interest rate is 2.8%. Okay? So the question is, find the amount of the annuity after the 18 years is over. Now, if you want to do this 1 year at a time, you can do that, but it will take you a little bit of time, okay? So I have a better suggestion for you. I think it's a better suggestion. Let's just take a look at the first year, second year, third year, and see if we can look for a pattern, okay? So see if this makes sense. The first year, $2,000 was invested, okay? So to find your total amount, remember I taught you, remember I just taught you way back here. Yes, you are more than welcome to. Yes, you are more than welcome to take 2,000 times 2.8%, which is 0.028, and then whatever you get, add that back to the 2,000. That's fine, but that's the longer way. I just told you, if it's an increase, you can add 100 to it. So if I have 2.8%, and I add 100 to that, I would get 102.8%. Move the decimal 2 places, and I'm going to multiply 2,000 times 1.028. If I did that, I will see the amount for the first year. Now, you don't have to type that in. Don't do that. If you did, you would see the person now has $2,056. But I'm not too worried about that. I just want to show you how much money they had at the end of the first year. Got it? That's how much money they have at the end of the first year. 2,000 times this. Now, you come to year 2, and what are you going to do? Well, year 2, don't forget, guys, year 2 has this amount of money already in the bank, right? So when year 2's over, we had this, plus your great parent that you had added how much? 2,000. Then you multiply, that's how much is in the bank. This is in the bank from year what? This is in the bank from year 1. Plus your mom or dad put 2,000 more into it, and this whole group gets multiplied by 1.028. So it would look like this. There it is. 2,000 brought this down right here. 2,000 times this plus 2,000 times this. Now, I want to throw something out at you. Look for this really cool pattern, okay? Not sure what just happened, but I don't think I wanted that. I'm not sure at all what just happened. But anyways, look at this pattern here. If you took, this is one term because they're multiplying. Let me change colors to make this easier to see. This is one term because they're multiplying, and this is one term here. There's a plus sign that splits them up. If you took 1.028 and multiplied it by this, you would have 2,000 times 1.028 times 1.028, which is the same thing as 2,000 times 1.028 to the second power. It would look like this: 2,000 times 1.028 times 1.028, which is the same thing as 1.028 to the second power. Okay? Then if you multiply this times this term, you have 2,000 times this. Maybe I'm seeing a pattern here. 2,000 times this, power of 2. 2,000 times this, power of 1. Let's see, let's go on to year 3. Now, you understand, for year 3 students, hold on one second. For year 3, let's just do this. For year 3, I would have all of year 2. Here's all of year 2 right here. I would have all of year 2, right? For year 3, I'd have all of this. Plus, your gracious mom and dad would add another $2,000 here. So because your parents would add another $2,000 here, this is all your money now, okay? That's how much you have at the end of year 2. So year 3, you'd have all of that plus another $2,000, and then all of this will be multiplied by 1.028. So it would look like this right here. Now, let's do some simplifying. If you start on the inside and take this and multiply it through, you would have 2,000 times 1.028 to the second power. This times this would be plus 2,000 times 1.028 plus 2,000. And of course all of this would get multiplied by this right here. So trust me, you'd end up with 2,000 times 1.028 to the third power plus 2,000 times 1.028 to the second power. I'd multiply this times this term, this times this term, and this times this term. Alright? And as I did that, all of my powers will increase. So here I have a third power, here a second power, plus then 2,000 times 1.028. So you're seeing the pattern. For year 1, I have a power of 1. For year 2, a power of 2 and a power of 1. So for year 3, a power of 3, a power of 2, and a power of 1. So with that there, we can go ahead and surmise and say for year 18, we're going to have 2,000. Well, my pen's not working over there. 2,000 times 1.028 to the 18th power plus all the way down to 2,000 times 1.028 to the first power. Now I'm going to flip that. I'm going to say my first term is this right here. 2,000, sorry about that. And then plus all the way to 2,000 times 1.028 to the 18th. Why is that a big deal, Mr. Aaron? Are you kidding? Because you're multiplying each term by the same thing. Look, we have a geometric sequence. We multiplied this term by 1.028. Then the next term had 2. 1.028 to the second power. We multiplied each term by 1.028. So our common ratio for this is 1.028. My first term would be 2,056. Where did I get that? Well, 2,000 times 1.028 is this. So if I want to find the sum of all this whole expression, this is the big expression for year 18. Let's go back a page. This is the expression for year 1. Got it. This is the expression for year 2. Got it. this is the expression here for year 3. That whole thing. So year 18 is going to be this whole expression here, adding all these terms up. So here's the formula for finding the sum of a geometric series or sequence. It would be A subscript 1 parentheses 1 minus r to the n parentheses over 1 minus r. Okay? Now, let's see what we can do, okay? My A subscript 1 is going to be 2056. R to the n. Now, n is your number of terms, and I have 18 terms. So I have 1 minus 1.028, which is my common ratio, to the 18th power. Alright? All over 1 minus r. Well, 1 minus 1.028 would be negative 0.028. If I'm doing any of this too fast, just use a calculator. You'll see that I'm correct, okay? Now, with my calculator, I'm going to take this. I'm going to take this expression right here. Right here. 1 minus 1.028 to the 18th power. And you should get this. If you're doing it correctly, you should get negative 0.6439025301. Let me say it again. And don't clear your screen. Leave that on your screen. You should get 0.6439025301. And then times 2056. And when you do that, you're going to get this number here. I'm going to round up. It's going to be negative 1,323. Since we're dealing with money, I'm going to go to 2 decimal places. 0.86 all over negative 0.028. So take this number here, divide it by a negative 0.028, and you're going to get 47,280.84. Now, let me say this. That's not the answer in the back of the book. I disagree with the back of the book. The back of the book has for their answer $45,993.04. Here's what they did. I found this to be really weird. They called the first term 2000. So they're saying year 1 is 2000, and then your very last year would be 2000 times 1.028 to the 17th power. That makes no sense to me because they're basically saying you put 2000 in at the end of the year, so it didn't get any interest. That's not how it's going to work. You're going to put this in right away, so you get interest on the first year. At least that's my opinion. Okay? So, anyways, there it is. There's the answer. Hope that made sense. Okay, guys? If you have any questions, don't hesitate to